Hello everyone, welcome to Edimon tutorials on signals and systems. Hope you guys are doing your exams well. As you have SS exam, I would like to discuss the previous paper written by your seniors. So let's have a quick glimpse of the question paper. As you know, the first question consists of 7 sub-questions, each with 2 marks, and from the remaining 7 long answers, you need to attempt any 4. Right. So let's start with the 2-mark questions. So the first question is evaluate integral of minus infinity to infinity e power minus 80 square delta of t minus 5 dt. So this is your impulse function. So from the properties of unit impulse function, we have integral of minus infinity to infinity x of t delta of t minus t naught dt is equal to x of t naught. So in this equation, put x of t is equal to e power minus 80 square and t naught is equal to 5. On substitution, we'll get x of 5, but your x of t is equal to e power minus 80 square. So put t is equal to 5 and you'll get e power minus a into 5 square, which is equal to e power minus 25a, which is the required answer. So next question, write the expression of trigonometric Fourier series. So this is something you have to remember, that is x of t is equal to a naught plus summation n varying from 1 to infinity a n cos n omega naught t plus b n sin n omega naught t. So your a naught, a n and b n are Fourier coefficients and their formulas respectively are given. Next, find the Fourier transform of e power minus 2t into u of t. The formula for Fourier transform is this, that is x of omega is equal to integral of minus infinity to infinity x of t e power minus j omega t dt. So your x of t is given in the question, so substitute it here, and u of t is the unit step function whose value is 1 for t greater than or equal to 0 and 0 for t less than 0. So your integral now becomes 0 to infinity e power minus 2t, u of t value is 1 in this integral, so into e power minus j omega t dt. This is in the form of a power m into a power n. This will be a power m plus n. So this is the next step, and on integrating this along with its inner derivative bounded to the lower and the upper limits. So on substitution of the upper limit minus lower limit, you will get 1 by j omega plus 2. Next, find the convolution of x of n and h of n. Okay, 2 sequences are given and you need to find convolution. Basically, to perform convolution, you have 3 methods. One is a graphical method, the second is a matrix method, and the third is a tabular method. Since this is asked for 2 marks, you either go for tabular method or matrix method. And if the same question is asked for 7 marks, then you need to do graphical method. So write your h of n sequence here and h of n sequence here, and perform multiplication. Here 1 into 2, 1 into 4, 2 into 2, 2 into 4, 3 into 2 and 3 into 4. So your y of n sequence for the first element will be 2, the second element will be 4 plus 4, the third will be 6 plus 8 and the fourth element will be 12. So this is our required y of n sequence. Next, find the Laplace transform and the region of convergence of x of t. So the formula for Laplace transform of e power at into u of t is equal to 1 by s minus a. So on applying this formula to the first and the second terms, we'll get 1 by s plus 2 plus 1 by s minus 3. So we'll obtain the poles now by equating the denominator to 0. So you'll have s is equal to minus 2 and s is equal to 3. So the real part of s now lies between minus 2 and 3. So the region of convergence, as we know, the Laplace transform is vertical lines parallel to the j omega axis. So I represent it this way, and the region of convergence lies between minus 2 and 3. So on x axis, the region of convergence lies between the poles minus 2 and 3. Define power density spectrum. This is just a basic definition. So it is a measure of how the average power of the process is distributed with respect to frequency. So, and its formula is s x of f is equal to limit t tends to infinity expected value of mod x of f square by 2t. Next, they asked us to define Nyquist rate. So the minimum sampling rate of 2 into fm samples per second for a signal x of t having maximum frequency of 2 into fm hertz is called Nyquist rate, and its formula is 2 into fm hertz. Next, what are the various operations performed on a signal? Give example. These are long answers. So the first operation is a time shifting property. and it is represented by x of t is equal to x of t minus t naught. If your t naught is positive, then the signal is delayed by t naught units. And if your t naught is negative, then the signal is advanced by t naught units. Let us have an example. This is u of t, and you have a time shifting of t minus 1 by 2. So 1 by 2 here is positive, that is you have a delay in the signal. So the signal, instead of starting at 0, it started at 1 by 2. Time reversal. The time reversal of a signal x of t can be obtained by folding the signal x of t about t is equal to 0. So when you fold the signal about x of t is equal to 0, you'll get x of minus t. This is the time reversal operation. Coming to the time scaling, if you replace this t with at, then you'll get a time scale signal. Here for x of t, you replace it with x of 2t. What happens here is you have minus 1 here, that is halved, minus 0.5, and 3 is halved to 1.5. That is, if you multiply a t with 2, it is halved, that is, it is compressed. And if the same signal is multiplied by a factor of 1 by 2, then you'll have an expanded signal. That is, your minus 1 is doubled and 3 is doubled to 6. The next operation is the amplitude scaling. So if you take a signal x of t and you feed this to an amplifier, you'll get an amplitude increase in amplitude. So here this is your x of t, and when you amplify it, it can be n into x of t, where n can be any value, which is y of t is equal to n into x of t. Our next operation is signal addition and subtraction. So the sum of two continuous time signals can be obtained by adding their values at every instant, and the same goes with subtraction, that is subtracting the two signals at every instant. Consider two signals here, x1 of t and x2 of t, and if you want to add these both, so from 0 to 1 its value is 1, and here from 0 to 1 you'll have 1, so 1 plus 1 will be 2, so the addition of these two signals you'll get 2. And similarly from 1 to 2 you have 2, and 1 to 2 you have 0.5. If you add these both, you'll get 2.5, which is the output of the addition of signals. Similarly with the same goes with subtraction. Coming to the signal multiplication, you multiply both the signals at every instant. Here you have x1 of t and x2 of t, right? So x1 of t is a slope from 0 to 1, and your x2 of t is this, whose value is 1. So you multiply this both. So 1 into any signal will give you the same signal. So in the output we got the same signal. So from 1 to 2 you have 1 here, and 1 to 2 you have 0.5. So 0.5 into 1 will give you 0.5. So in the product of the two signals you got 0.5. Coming to the next question, they gave you input signal x of t and the impulse response h of t, and you need to determine y of t. You're familiar with this system, that is, you'll give input x of t to an impulse function h of t, and you'll get y of t. You will obtain y of t by convoluting these two signals x of t and h of t. So y of t is equal to x of t convolution h of t, which is equal to integral minus infinity to infinity x of tau h of t minus tau d tau. You have x of t with you, so replace t is equal to tau, and you have h of t, replace t is equal to t minus tau, in that you'll get h of t minus tau. On substitution you'll get this. So your u of tau is 1 for tau greater than or equal to 0 and 0 for all the other values, and u of t minus tau is 1 for tau less than or equal to t and 0 for all the other values. So your integral now becomes 0 to t, and your u of tau and u of t minus tau values will be 1 in this particular integral. You'll obtain this. Here e minus 4t is not a function of tau, so take it out and perform integration to this function. On applying the upper and the lower limits, you'll get this equation, which is your y of t. Next, for the continuous time periodic signal, okay, x of t is given. Determine the fundamental frequency omega naught and the Fourier coefficient Cn. So consider this signal. First we need to find the time period. So we have two functions. Consider the first function and find its time period. T1 is equal to 2 pi by omega 1. So your omega 1 is a coefficient of t, which is equal to 2 pi by 3. On substitution you'll get T1 is equal to 3 seconds. And the time period of the second function is sine, And for that, we'll find the time period, which is equal to 2 pi by omega 2. Your omega 2 is a coefficient of t, which is equal to 5 pi by 3. So now your t2 becomes 6 by 5 seconds. Now compute t1 by t2, which is equal to 5 by 2. On cross multiplication, we'll have t is equal to 2 into t1 is equal to 5 into t2, which is equal to 6 seconds. So you got your time period. Now we have to find the fundamental frequency omega naught, which is equal to 2 pi by t. You already got t is equal to 6 seconds, so substitute it here, and your omega naught will be pi by 3. They even asked for Cn. So again, consider the signal. You know that here pi by 3 is omega naught, so replace pi by 3 with omega naught. And in the next step, convert this cos trigonometric function into the exponential function. Since cos theta is equal to e power theta plus e power minus theta by 2, and your sine theta is equal to e power theta minus e power minus theta by 2j. On solving this, you'll get your x of t. Now compare this x of t with the standard equation. X of t is equal to summation n varying from minus infinity to infinity Cn e power jn omega naught t. So at particular n value, we have Cn values. So at n is equal to minus 5, you have Cn is equal to 2. At n is equal to minus 2, you have Cn is equal to 0.5. At n is equal to 0, you have Cn is equal to 2. At n is equal to 2, Cn is equal to 0.5. And at n is equal to 5, Cn is equal to minus 2. Thus, you need to mention it here. And this is what we require. So next question, find the exponential Fourier series and plot frequency spectrum for the full wave rectified sine wave. So this is your full wave rectified sine wave. And its time period is 0 to 1. So your time period t will be 1. And the fundamental frequency omega naught is given by 2 pi by t. Your t value is 1. So your omega naught will be 2 pi. Since the signal from 0 to 1 is sine pi t, so x of t is equal to sine pi t in the interval 0 to 1. You know that the c naught is equal to 1 by t integral of t naught to t naught plus capital T x of t dt. Your t is equal to 1, x of t is equal to sine pi t. On substitution and integrating it, you will get this value, that is your c naught is equal to 2 by pi. Our next thing is Cn, whose formula is 1 by t integral of t naught to t naught plus capital T x of t e power minus j omega naught nd. Again, the same goes here. Your t will be 1, x of t is sine pi t, and your omega naught is equal to 2 pi. On substitution, you'll solve this. Here 1 by 2j is constant, so take it out and multiply these terms. Now this is in the form of a power n into a power n. This will, so a power n plus n in the next step. You'll integrate this, bound it to the lower and the upper limits. Substitute the upper limit minus lower limit. You'll get this particular equation. Since e power j into 1 minus 2n into pi is equal to e power minus j into 1 plus 2n into pi is equal to minus 1. On substitution, we will get Cn is equal to 2 by 1 minus 4n square into pi. So for take different n values, you'll have Cn values. On substitution, they asked us to plot. So we are taking these values and we plot this. If you observe at 0, you have 2 by pi. So I plotted this here. And from 1 and minus 1, we have the same amplitude values. So the amplitude values are same. And for the same goes with 2n minus 2 and 3n minus 3. The next question is find the Dtft of the following sequence. You have two sequences. So the formula for Dtft is x of e power j omega is equal to summation n varying from minus infinity to infinity x of n e power minus j omega n. Your x of n is given in the question. Substitute it here. Your u of n minus 1 is equal to 1 when your n is less than or equal to minus 1 and 0 in all the other cases. So your summation now becomes n is equal to minus 1 to minus infinity minus a n e power minus j omega n. So replace minus n to n. So your these negative values will become positive. Your n will become minus n and your minus n will become plus n. So take the nth power common. This is in the form of GP. So your on solving, that is a by 1 minus r, your first term a is a power minus 1 into e power j omega by 1 minus r, which is your common ratio. On solving this, you'll get your required answer. Next, find the Dtft of cos omega naught u of n, this same formula as you did above, and your substitute your x of n since u of n is equal to 1 for n is equal to 0 to infinity, this step is obtained, and convert this trigonometric cos into exponential function, that is cos theta is equal to e power theta plus e power minus theta by 2. Split this and multiply this. This is in the form of GP now, so a by 1 minus r, which is equal to this. Our next question is explain energy density spectrum and frequency response. So what energy density spectrum is? It measures the signal energy distribution across frequency, and it is defined as psi x of f is equal to mod x of f whole square. Since your signal energy is given by integral of x of t mod x of t square dt, so this, if you mention it in the frequency domain, since energy spectrum, the distribution is across frequency, this x of t in the frequency domain will be mod x of f whole square, which in turn equal to psi x of f. So we got this. And the properties of energy spectral density are psi x of f is greater than or equal to 0, that is, it is always a positive value. It is symmetric, that is, psi x of minus f is equal to psi x of f, and the input and the output spectral densities, energy spectral densities, are related this way. And the frequency response, as you know, for different values of frequency, input frequency, we'll have different output values. So your x of j omega is the system input, h of j omega is called the frequency response, and y of j omega is the system response. The relation between these three are given by y of j omega is equal to h of j omega into x of j omega. So your h of j omega now is equal to y of j omega by x of j omega. This is your frequency response. So next question, perform the circular convolution of the sequences x of n and h of n using DFT and IDFT. So let us suppose that the first sequence is x1 of n and the second sequence is x2 of n. They asked to perform circular convolution between these two, and the result will be x3 of n. So to obtain this x3 of n, we first need x3 of k. To obtain x3 of k, we need the multiplication of x1 of k and x2 of k. So our first step is to find x1 of k. Second step is to get x2 of k. On performing multiplication of these two, we get x3 of k, and performing IDFT for this x3 of k, will get x3 of n, which is our required sequence. So the formula for x1 of k is equal to summation n varying from 0 to n minus 1 x1 of n e power minus g 2 pi by n kn. So your k values varying from 0 to n minus 1. So this is your x1 of n sequence. You have 4 elements here, so your capital N is equal to 4. So you'll have x1 of 0, 1, 2 and 3. N varying from 0 to n minus 1, your n is 4, so n minus 1 will be 3, x1 of n, so e power 0 will be 1. So on solving this, you'll get 5. Similarly for x1 of n, 2 and 1, 2 and 3, you'll get this values. So here you obtain your x1 of k sequence. The next is to obtain x2 of k. The formula for x2 of k is summation n varying from 0 to n minus 1, x2 of n e power minus j 2 pi by n kn. As you know, k value from varying from 0 to n minus 1. So your x2 of 0 is summation n varying from 0 to 3, x2 of n, you'll get x2 of 0. Similarly, you'll find x2 of 1 by putting k is equal to 1 in this. x2 of 2 and x2 of 3, you'll get the values. And your x2 of k sequences now becomes this. Next, the third step is to obtain x3 of k by multiplying the two sequences that we got above. On multiplication, we get this sequence. Our main motive is to get x3 of n. So perform IDFT for x3 of k. So the inverse DFT of x3 of k is given by 1 by n, summation k varying from 0 to n minus 1, x3 of k into e power j 2 pi by 2 pi nk by n. In DFT, we have minus here, whereas in IDFT, we'll have plus. So on applying this formula, 1 by n, n is equal to 4, n minus 1 will be 3, your x3 of k. So on x3 of k sequences here, on substitution of all this, you'll get your x3 of 0. Similarly for x3 of 1, 2 and 3. And the final sequence that we need will be obtained. Next, a function x of t has a power spectral density of s x of omega. We need to find a power spectral density of integral of x of t and the time derivative of x of t. This is the power spectral density for x of t. right? So Sx of omega is equal to limit t tends to infinity, expected value of mod x of j omega whole square by 2t. Here your x of j omega is a Fourier transform of x of t, but they asked for integral of x of t. So find the Fourier transform of integral of x of t, which is equal to x of j omega by j omega. So your power spectral density of integral of x of t will be limit t tends to infinity, expected value of, instead of x of j omega, we'll have x of j omega by j omega. Since integral Fourier transform of integral of x of t is equal to x of j omega by j omega. Here your j square will be minus 1 and omega square. So take it out, minus 1 by omega square. If you take this term out, and whatever is left will be the Sx of omega. Next, find the Fourier power spectral density of derivative of x of t. So the Fourier transform of derivative of x of t is equal to j omega into x of j omega. So Sy of omega is the power spectral density of derivative of x of t. So the limit t tends to infinity, expected value of j omega into x of j omega whole square by 2t. Here j square is minus 1 and omega square. Take this term out. You'll obtain this, and take this minus omega square term out, and you'll, whatever is left will be Sx of omega. So next question, state and prove any four properties of Laplace transform. So the first property is linearity. If the Laplace transform of x1 of t is equal to x1 of s and Laplace transform of x2 of t is equal to x2 of s, then your Laplace transform of a into x1 of t plus b into x2 of t will be a into x1 of s plus b into x2 of s. So consider the LHS. So perform Laplace transform. You know that integral 0 to infinity x of t into e power minus st dt. So split this integral. Here a is constant, so take it out, and whatever is left is the Laplace transform of x1 of t, which is equal to x1 of s, and take this b constant out, and whatever is left is a Laplace transform of x2 of t, which is equal to x2 of s. The next property is a scaling property. If Laplace transform of x of t is equal to x of s, then the Laplace transform of x of et is equal to 1 by mod a x of s by a. So consider LHS and apply the Laplace transform formula. In the second step, multiply and divide it by a. Now let us suppose that at is equal to p. Perform derivation on both sides. You will get a into dt is equal to dp. So your dt is equal to dp by a. So on substitution of all these, you will get this. Here 1 by a is constant, so take it out. So integral 0 to infinity x of p e power minus of s by a into p dp. This is your Laplace transform of x of p, which is equal to x of s. But instead of s, you have s by a. So this will be x of s by a. Next, time shifting property. We know that the Laplace transform of x of t is equal to x of s. If you have a shift in time, that is t minus t naught, then in the frequency domain, the x of s will be multiplied by e power minus s into t naught. So consider LHS. This is apply the formula integral of 0 to infinity, whatever the signal here will be mentioned here, and e power minus st dt. Suppose that t minus t naught is equal to p. Perform derivation on both sides. So dt is equal to dp. On substitution of all these, you will get this. Now split this. You will get e power minus sp into e power minus st naught dp. Here e power minus st naught is not a function of p, so take it out, and whatever is left is a Laplace transform of x of p, which is equal to x of s. Our next property is a frequency shifting property. That is, we have a shift in the frequency, right? So consider this LHS. So Laplace transform of e power minus 18 to x of t is equal to integral of 0 to infinity e power minus 18 to x of t into e power minus st dt. So this is in the form of a power m into a power n. So this will be a power m plus n. This is the Laplace transform of x of t, but instead of s, we have s plus a. So that will be x of s plus a. The next question is find the inverse Laplace transforms for the following signals. So the first signal is given from the knowledge of partial fractions. You can write it as a by s plus 1 plus b by s plus 1 whole square. Take LCM. and you'll get this. In this equation, if you put s is equal to 0, you'll obtain a plus b is equal to 1, and if you put s is equal to 1, you'll obtain 4a plus 2b is equal to 1. On solving these two equations, you will get your a and b values. So substitute your a and b values in this. Now apply Laplace transform on both sides. So you know that Laplace transform of 1 by s minus a will be e power minus at into u of t. So based on the formula, you will get this step. They even asked to find the inverse Laplace transform of 1 by s plus 1 whole square plus 1. We know that Laplace transform of sine at is equal to a square by s square plus a square. Put a is equal to 1. So your Laplace transform of sine t will be 1 by s square plus 1. But in the question, you have s plus 1 instead of s. So you need a frequency shift property. So by frequency shift property, Laplace transform of x of t is equal to x of s. And for Laplace transform of e power minus t into x of t will be x of s plus 1. So here you have you had a shift, that is Laplace transform of e power minus t into sine t will be 1 by s plus 1 whole square plus 1. The asked question is inverse Laplace transform of this. So this is the required answer. Next, using final value theorem, find x of infinity if x of z. Okay, x of z is given and you need to find x of infinity. The formula for x of infinity is limit z tends to infinity, z minus 1 into x of z. So your x of z is given in the question, substitute it here. And now your limit z tends to 1, substitute z is equal to 1 in this equation, and your answer will be 0. So your x of infinity is 0. The next question, x of z is equal to z plus 2 by 4 into z minus 1 into z plus 0.7. Apply the same formula according to final value theorem. So your z minus 1 and here z minus 1 and x of z will be cancelled, and you're left with this. Now substitute z is equal to 1. This is on solving, you will get x of infinity is equal to 0.44. The next question is explain the signal recovery from its sample signals. Okay, you have a condition here, that is to obtain the original signal from its sample signals, the sampling rate should be above the Nyquist rate. That is omega s should be greater than or equal to 2 omega. That is to avoid aliasing effect, right? So you're giving a sample signal to your low pass filter h of t. You're obtaining your original signal x of t. If you had studied the sampling, this is the equation for the sample signal. Xs of t is equal to summation n varying from minus infinity to infinity x of nt delta of t minus nt. For that, it's the Fourier transform will be this. So in order to obtain the original signal from the sample signal, this is the formula, that is the sample signal convoluted with the impulse signal h of t. So you know your xs of t equation, substitute it here. And now performing convolution, you'll get this step, and your delta of lambda minus nt is equal to 1 for lambda is equal to nt and 0 for all the other values. So you obtain this step. Now your h of t minus nt, you need to obtain this. For this we need to know the frequency response of the low pass filter. So according to the Nyquist rate, omega should be less than or equal to omega s by 2, in which h of j omega is equal to t. So the impulse response h of t we need, so that will be equal to 1 by 2 pi integral of minus omega s by 2 to omega s by 2 h of j omega. In this interval, you have h of j omega is equal to capital T. So you'll substitute capital T, it is a constant, so take it out. On solving this, you'll get t by pi t sine pi t by capital T. We need h of t minus nt, so replace t by t minus nt, you'll get this particular equation. So now this is your sinc function. If you observe, that is sine nt by t will be your sinc function. So I replace this with sinc. This is your required original signal from the sample signals. Our next question is find the frequency response of the following system. A system equation is given and you need to find the frequency response. So write the given equation, perform Fourier transform on both sides, then you will get y of e power j omega. For y of n minus 1, it will be e power minus j omega into y of e power j omega. Similarly for the rest of the terms. And on the left hand side, take y of e power j omega common. You are left with these terms, and on the right hand side, take x of e power j omega terms constant, and you're left with these two terms. So now you will obtain y of e power j omega by x of e power j omega, which is equal to this. Finally, we need h of e power j omega, which is equal to y of e power j omega by x of e power j omega, which resulted in this. Our final question is find the linear convolution of sequences. Okay, two sequences are given. We need to perform linear convolution, and observe this carefully. This is using Dft. Okay, so this is completely similar to convolution, that is circular convolution, except that you have an extra step here, that is the step 1. You have to find the length of the output sequence, which is equal to L plus m minus n. Your L is the length of x of n, and your m is the length of h of n. So on substitution, you will get your n is equal to 3. So we need to obtain the new sequences. So x of n is this, but we need to pad extra zeros to obtain a new sequence to the length 3. So from the next step, the same goes as you did in circular convolution, maybe in the 5th sum, I guess. So I'll tell you this briefly. Your x of k, first in the second step, you need to calculate x of k by using the formula. In the second step, you need to calculate h of k using the same formula. And in the third step, you perform multiplication of the two sequences obtained, which will result in y of k. And the next step, you need to obtain y of n, which is your inverse Dft of y of k. So you'll obtain your y of n sequence. Just go through the 5th sum. This is similar to that, except that you'll have a step 1 here. So this is the end of the paper. Hope this paper is clear to you guys, and I wish you all the best for exams. Thank you.